Hello again. So this is the third video in behavioral sciences. We'll talk today about the measures of central tendency. So let's start by talking about the mean. So the mean is the sum of observations divided by the number of observations. You have to note here that the mean is sensitive to extreme scores or values. So it's not very good measure of central tendency in bell-shaped or normal distribution curves. While the median is the middle observation, but only after rearranging the scores or the observation in ascending or descending. Usually it's in ascending manner, and it's the least affected by extreme values, so it's a good measure in skewed curve. So we said it's the middle after rearranging, the middle observation after rearranging. If the observation are odd, that's easy. Getting the middle observation is easy. Dividing the number of observation plus 1 divided by 2, you'll get the middle. But if it's even, then the median is the average between the two middle observations. So after getting the middle, you have to add 1, and then we'll talk about how to do it in the example. The mode is the most frequent, it's the easiest one, the most frequent value occurring. So let's talk about an example here. So we have this set of values, and we are asked about the mean. So what we do is we add them all and divide them by the number, which are the 6 values divided by the number will give us the answer. And then the mode is the most frequent one, which is 5. So that's easy. Example 2 here. These are the observations. Know that they are correctly arranged here. If they weren't, you would have to arrange them again before doing them. And they're odd. So the median is there are 5 observations plus 1 divided by 2. So the third. 1, 2, 3. So this is the third observation. That's the mean, number 8. That's the median, number 8. While in third example, we're asked about the median, but they're also arranged, and we're asked about the median. If we divide the number 4 by 2, it gives us 2. So the second observation. So it's actually not the second observation, it's the second between the second and the third. So 6 plus 8 divided by 2, so it's number 7. The median is 7. How about the range? The range is easy. It's the difference between the largest and the smallest values. So in this example, the largest 9 minus the smallest, this is the range. What's the average? In the average, we have to sum the total number of observations divided by the sample size. So that's a little bit different. So let's look at this example here. In a random sample of children, the number of episodes of UTIs are as follows. So 50 children got 0, then 30 children got 1 episode, 10 children got 2, 10 children got 3. So how do you get the average here? So you have to get the number of UTIs by multiplying the number of children by the episodes, the number of episodes they got. So, and then adding them all together, we'll get that they had 80 episodes per year. Then the number of the sample size is are the number of children. So we add the number of children here. We'll get that there are 100 children. Then divide the number of episodes by the number of children. We'll get 0.8, which is less than 1 attack, less than 1 per year. So what's the normal distribution? This is a normal distribution curve. It's usually a bell-shaped curve. It's where the mean and the median and the mode are all the same, are all equal. They're all the same. But what happens if there is a positive skewed or negatively skewed curve? If we have some extreme values that are positive the curve tends to be positive, the tail to the right side. In this position, the mean is larger than the median, because the mean is the most one affected. We said before, the most one affected by positive values or extreme values is the mean. Then the median is larger than the median is larger than the mode. And the median is usually the best, is a better measurement of central tendency. So how I remember this, the tail is positive toward the right, so it's a positive. So write mean, median, mode from the right to the left, and you'll get it. Mean is larger than the median, larger than the mode. If we have an extreme value toward the negative side, the curve would be skewed. The tail would be towards the left, or the negative side. So write them the opposite side. The mean, median, mode. So the mean is smaller than the median, smaller than the mode. The median is the better measurement of central tendency. So we said there is a normal distribution curve. So it has some characteristics that we have to know. So this graph is very important. So this is the mean here. In a normal curve, there's a set of values between the standard deviations. The standard deviation is the value that measures how away a value is from the mean. So within one standard deviation plus and minus, there are 68% of the population that lie in a normal distribution curve that lie between these two values. Between two standard deviations, 95.5%. Between three standard deviations, 99.7%. So you have to know not only the percentage here, but each one, the numbers here. So as we said here, try to make it like this. Okay. So here the mean equals the median equals the mode. 68% are within one standard deviation from the mean, plus or minus. 95% within two standard deviations, and 99.7% within three standard deviations. So let's look at an example. If a population's resting heart rate is normally distributed, the mean is 70 and the standard deviation of 10. So in this example, 68% of the population resting heart rate lies between one standard deviation. So one standard deviation is, the mean is 10. So 170, which is the mean, plus or minus 10, which is one standard deviation. 95% of the population lies between two standard deviation, as we said here. So 2 times the standard deviation, so 2 standard deviation, and this is the mean. So plus or minus 2 plus times the standard deviations. So in inferential statistics, we try to select samples that are representative of the entire population. That can't be true all the time. So we want to generalize a result of a sample to a population. We use the inferential statistics and try to do that using the confidence interval. So the confidence interval allows us to say how confident are we that the results from this sample can be generalized to the entire population. So the 95% confidence interval allows us to say that we are 95% confident that the true mean falls between the values that we are set. So what's the equation? the confidence interval equals the mean plus or minus z square. Z, we're usually given the z, or it's very easy. If they ask for the 95 confidence interval, it's 1.96. If they ask about the 99% confidence interval, it's 2.58. The 99 confidence interval, we're very sure, but it's going to have a wider confidence interval than the 95. So times the standard error of the mean. We want the standard error of the mean to be a smaller number in order to have a tight confidence interval. So getting a smaller number here requires increasing the s, decreasing smaller number. So we either decrease the s, that's the standard deviation, or the sample size, make it larger. So the larger sample size, the tighter confidence interval, because we'll have a smaller standard deviation, standard error of the mean. So this is a very important equation to know. Let's look at an example, or let's look at some relations here. So if we have the confidence interval is directly related to the standard deviation. As we increase the confidence interval, the standard deviations increases too. The confidence interval is inversely related to the sample size. If you have a large sample size, the confidence interval would be narrower. While we have a low sample size, the confidence interval will be wider. We can get all these relations from the equation, and it's important to know them. So one way of asking it would be in meta-analysis. What type of confidence interval would we have? So meta-analysis, we have data from multiple studies, so the sample size would be larger, so we have the lowest confidence interval. When they ask us to compute the confidence interval, they usually give us the mean and the standard deviation and the sample size. We have to use the equation, mean plus or minus the z, which is, we can get it from the 95 confidence interval, times the standard error of the mean, standard deviation divided by the square root of the sample size. So if we've made this calculation, it will be 67 plus or minus 4. So the 95 confidence interval will be from 71 to 63. We're 95% confident that the mean would lie between these two figures. What happens if the confidence interval between two groups overlaps? Then we'd have no significant difference. For us, no difference. There will be some difference, but it won't be significant. So this example is from Kaplan. That this graph represents people with high blood pressure and certain drugs that act on blood pressure. We want to compare them. The 95 confidence interval. So drug A and B, they're overlapping. Drug B and C are overlapping. But drug A and C, they are not overlapping. So because B and C are overlapping, there's no difference in their effect. We can't conclude there's a difference. B and E, there's also no difference in their effect. But A, because it has a lower blood pressure, it makes the patients have lower blood pressure, is better than C. What's the confidence interval for relative risk and odds ratio? Here the null value, or the 1, if we have the 1, which is the null value here, if the confidence interval contains 1, there is no statistical significant effect of the exposure. So when they give us the relative risk and they give us the 95% confidence interval. So what we have to look first at the 95% confidence interval and see if it traverses the number 1 or not. So here it's 1.12 to 5. So it didn't traverse 1. 1 is not in between these two values. So that means it's significant. So the relative risk here is more than 1. It's 1.57. That means there's increased risk. Let's look at the other example here. The 95% confidence interval is 0.89 to 2.34. Here it traverses from 0.8 to get to 2.34. We'll get 1 in between. So it's not significant because it passes through 1 or traverses 1. So you don't even have to look at the relative risk value. Here, from 0.56 to 0.93, it didn't reach 1. And the relative risk is less than 1, so there's decreased risk. So this is it for today. Let me know what you think and study hard.